All right. So it's time to bring out the calculators again. We're going to have to start doing some calculations again. So I talked kind of about the idea of concentrated or diluted, but now we're going to have to do some things that are more quantitative. And you may have noticed in the lab, you may have noticed things like next to all the, like on the bottles where we have hydrochloric acid, HCl, you might have seen like a little 1M or a 2M. This is actually referring to concentration. This is referring to the idea of how much solute is in a given amount of solution. So that's all concentration is. Concentration, you can think of it a little like density, right? It's sort of like if you look at a solution, if you have a solution, you have a given volume of a solution, there is a certain amount of solute dissolved in there. And the more solutes you have per given amount of volume or per given amount of solution, the more concentrated it is. Now the density of the solution is different because that's talking about the whole thing, the water and everything included. But when we're talking about concentration, we're just talking about the solute only, how much solute is in a given volume. So you can think of it as solute density, really. Now, there's a couple different ways to express concentration. So there's different units of concentration. So a lot of times students get these kind of terms mixed up. They will think that concentration is synonymous with molarity, which I'm going to talk about in a minute. But molarity is just a unit of concentration. That's like thinking that mass and grams are synonymous, right? Grams is just one possible unit of mass, right? So concentration is this general idea of how much solute do I have in a given solution. One of them is molarity. Molarity is an expression of the moles of solution, or sorry, moles of solute over the liters of solution. Now, notice this is liters of solution. This is not liters of water or solvent. This is of the whole thing together, right? So, this is the total volume of both the solute and the solvent, not just one. So that's one possible unit of concentration. A couple things I want to say about molarity before I move on. One, this unit, M, is a compound unit, or a derived unit. It's shorthand for moles per liter. So you can always break molar, capital M, into moles per liter. And the way I say the unit is molar. So if I see something that's 3M HCl, the way I say that is 3 molar HCl. That's how the M unit is. Molarity is describing the measure itself. And as you might be able to predict, I think the easiest way to think of this is as a conversion factor like we did with density. So let's say, let me give you a more realistic number like with significant figures and everything. So 2.50 molar HCl, I would think of that as 2.50 moles HCl per 1 liter of solution. Right? Okay. A couple different ways to express concentration. There's actually 3 different ways to express percent. Right? And remember, percent is percent for each 100. Right? But it totally depends. Am I talking by volume, by mass, by mole? What do I mean? So there's 3 different ways. There's percent by mass that can also be abbreviated percent MM. And older books might say percent WW because they're using weight, but that's not really technically correct. Percent by mass is the mass of the solute over the mass of the solution. Now again, this is solution. This is both the mass of the solute and the solvent together, right? Percent by volume. Volume of solute over volume of solution. And this is abbreviated often percent VV. Right? Mass volume percent. So, the mass of the solute over the volume. Now, units. Units are important, and this is often represented as percent MV. Now, units are important here in a sense. So in mass, in percent by mass, sort of like in Boyle's law and Charles' law, it doesn't matter what units of mass I use, grams, kilograms, pounds, whatever. as long as I have both the mass of the solute and the solution in the same units. With percent by volume, same deal. It doesn't matter as long as I have them both in the same units. But when we do mass volume, right, there's no direct comparison. You can't say they have to be in the same units because the units of mass and volume aren't the same thing at all. So you have to specify. So mass volume percent is the only one that's specified, and it's grams and milliliters, right? Now, if you had kilograms and liters, you'd get the same thing. But for the baseline, grams and milliliters is the masses we're using. Okay. It's represented by the following abbreviations, which I had down here. Okay, so that is the basic idea of, those are our units of concentration. We have 4 of them. We have molarity and 3 percents. Percent by mass, percent by volume, and mass volume percent. Should be fairly simple, fairly straightforward. A few things to keep in mind. Remember, we still can always have the density of a solution. So remember, density can still be used to convert between mass and volume of a substance. This is critical. We might need to do this at some point. The mass of the solution is the mass of the solute plus the mass of the solvent. However, I have to say, volumes, it is not true that volume of solution, it does not equal volume of solute plus volume of solvent. It doesn't work that way. And the reason is how they mix. I mean, the masses are, of course, going to add because you can't get rid of mass. You can't change the mass of something. But they pack differently together than they do separately. Now, the change may be slight, but volumes are not additive. That's an important thing throughout all of chemistry. Remember, volumes are not additive. You cannot add the 2 volumes together. Okay. And you can think of percent concentrations as a conversion factor also. So if I say sodium chloride in water, I have a solution of aqueous sodium chloride, 6.208 mass percent, I can think of it in these ways. I can think of it as 6.208 grams of sodium chloride over 100 grams of solution, or, interestingly, I can think of it as, so this is the easiest one. This is the obvious one, right? Grams per 100 grams. These other things that's important to understand also follow, but I'll show you how I got to these. But this one is the most obvious one, and the one I'm going to go to the most. So, because the masses are additive, right? If this is the amount of sodium chloride per 100 grams of solution, then it must be true that this many grams per this many grams of water, right? Because I subtract out, I take 100 grams minus 6.208, and I get 93.792 grams of water remaining, right? If I take out the mass from the solute, then only the mass of the solvent remains. So, then I could say there's that mass of water in 100 grams of solution. These could be useful to you. You can always get there other ways, but this is the one I really want you to remember. Remember this. So, just like we've always done. So, what this means, when you see 6.208 percent mass to mass, that means 6.208 grams of solute per 100 grams of solution. Okay. Take a moment and do a couple problems here. So what is the molarity of 10 grams of sodium chloride dissolved in enough water to make 250 milliliters of solution? So pause it and try this. And then try the second one also. Why not? These are fairly straightforward. Okay, hope you're ready. So the first one, what we need is we want the molarity. And we need moles of solute over liters of solution. So we need to get those. And notice the terminology I used, dissolved in enough water to make 250 milliliters of solution. So getting the volume of solution in liters isn't so hard. We just convert milliliters to liters. And I think we've gone far enough in the quarter that I can just do this, and you guys will be able to follow me and figure that out. Although I did write my number of significant figures incorrectly. So it should be 0.25, because 250 written this way, it only has two significant figures. Now, the tricky part is the 10 grams of sodium chloride. Right? I need it in moles, but we can do that. That's a thing we know how to do, right? So moles of sodium chloride, and so then I just need to figure out the molar mass of sodium chloride. So I just take the mass of sodium, and I get 58.44. Wow, I wrote that really terribly. I'm sorry, guys. 58.4. Crying out loud. 44 grams. All right, per 1 mole. And that gives me 0.1711 moles. Now, I should only really have 3 significant figures, but I only have 2 down here, right? And so when I divide that number by 0.25, I get my concentration of 0.68 molar. You might have gotten 6.9 because it was really close to that rounding. That had a rounding issue. So there you go. The second one. A solution contains 50 grams of water and 120 grams of solute. So, easy enough. Percent mass. Okay. So the mass of solute is 1.20 grams of solute. Doesn't even matter what the solute is. Now, hopefully you guys were paying attention and you didn't just put 50 down here, because that would not be correct. What should go down there? Should be 51.2 grams of solution. You have to add them, right? The water is only 50 grams, but the whole solution together has a mass of 51.2. And so you're dividing 1.2 divided by 51.2 times 100, and you get 2.34% mass.